Hi everyone, welcome to another tutorial video. In our today's video, I will go over how to read a raster file by using Python. And also, I will go over how to clip the raster file by using a shapefile and how to plot the raster information by using Python. So let's get started. So the first thing that I'm gonna do is in this folder, inside of this folder over here, reading raster that I previously created. You can see over here the raster that we are gonna use is in this folder over here, which is a detailed elevation model of 10-meter resolution. And this watershed, this folder over here called watershed, will be the it contains the shapefile that we're gonna use to clip the raster. So the first thing that we're gonna do, let's create a Jupyter notebook, and I'm gonna name it as a reading raster. Perfect. So the first thing that we need to do is remember import OS and escape m enter to hash. Let's create a title. So location of the folder. So over here, I'm gonna specify the location where is located this Jupyter notebook by using this command os.chdr. Between inside of the quotation marks. So I'm gonna just copy this location over here. So now I'm gonna create another title. Let's read the raster. As I mentioned before, the raster that we're gonna use in this video will be a detailed elevation model of 10-meter resolution. So in order to read the raster, I'm gonna use the library import xarray as xr. As you can see, so this package is not installed in my computer. So in order to install it, so you can type on Google xarray anaconda, go to the first link. We are gonna use this one over here. So you can either install the package by using the terminal. So over here, terminal, by copying and pasting the code, basically this, and click enter. Or let's close this. Or another way to do it is installing the package in the same Jupyter notebook that we are using. If you decide to do this, you need to put y over here. So in order to specify that you're gonna accept that the anaconda install this package once it's downloaded. So it will take some time. So now, as you can see, it was downloaded and it was installed. So what I'm gonna do is I'm gonna click I'm gonna comment this. So now if I run again the cell, so I don't have the error because this package is already installed. So now I'm gonna create a variable called raster, which I'm gonna use that specific variable to storage the raster information. I'm gonna call xarray, and there is a function called open rasterio. And over here I need to specify the location of the raster file. As I mentioned before, the raster file is located in this folder, detailed elevation model, and it is this folder. So I need to specify the location. So dem 10 meters, And so this is the folder over here, and this will be the name of the file, div. Need to close the quotation mark and also the parentheses. And I'm gonna call the variable just to see what is inside of it. Perfect. So by the way, xarray needs Raster to basically open the raster. So what we need to do is we need to install Raster. So let me do this. So let's go to Google Raster Anaconda. Now we're here again. So we need to copy this. And I'm gonna paste it. Okay, I'm gonna go over how to install by using terminal. Just as I mentioned before, copy in the terminal, click enter. So you will start looking for the package, and once you found it, it will request you to type Y if you want to install. So basically yes in order to proceed, or not. It should be Y, enter. Okay, now let's go back, and sorry, it should be this one. So now, as you can see, so we basically read the raster with this one and open the variable. So when we open the variable, so we realize that the raster contains one band, and the so you can see all the columns and the numbers of rows. So what we are gonna do is, in order to avoid this, so band the specific, and the shape. So what we can do is, we following by the parentheses, we can use the function squeeze. So this can be done if the raster that you are reading has just one band. So now when I read the raster by using the same function, and I added a squeeze, so you can see that the band number 1, so basically we directly read the information in the raster. If you want to avoid this, another way is, so I'm gonna put 0 just to make the difference. So over here, sorry, should be equal, and let's now. So if you want to choose this method over here, so you will need to specify the band. So now, as you can see, this result and this one over here is exactly the same. So you can use either a squeeze or specify the band. If your raster has more bands, so you can put the index over here. Remember, it starts at 0. Okay, so now let's read the shapefile. So now we read the raster by using xarray. So now let's read the shapefile that we're gonna use to clip the raster. So in order to do this, in order to read the shapefile, so we need to use upandas. If you have an error like calling the geopandas, and you have this error that I'm showing you over here, so what you need to do is, I'm gonna put a video in the description that you can follow and I went over how to solve this problem. Okay, so now I'm gonna create a variable called shapefile, and over here I'm gonna use the upandas function called read file in order to read the shapefile. So watershed, so basically this is the main folder, watershed, and we are gonna read this specific file. So now let's call, so you can see that there is just one polygon. So now what we need to do is, in order to clip the raster by using a shapefile, you need to make sure that the projection are basically the same. So reprojecting raster and shapefile to a common CRS. Okay, so the common CRS that we are gonna use, the common projection that we are gonna use is the 4326. So if we type raster Rio CRS, okay, if you have this problem, you need to import Rio xarray. As you can see, I haven't installed this package yet. So what I need to do is to go to Google and type Rio xarray anaconda. So this package will help you. There are some functionalities that you can use with xarray, such as looking at the projection of your xarray. Why? No. Now if I read this one, I read this one over here. So now, as you can see, if I use the Rio CRS function, so basically it will give me over my raster variable. So it give me the specific CRS, the specific projection that the raster has. So as you can see, it's this one over here, but I'm gonna change this one to a common one. So raster Rio reproject, and we are gonna use the 4326. Now if I type again, just to make sure, this over here, so I should get, instead of this one, so now that I change it, as you can see over here, so now when I check the CRS, so you can see that it's 4326. And now let's do the same thing for the shapefile. So CRS, so this is using this projection. So for the in order to change the projection in a shapefile, so the function is quite different. So shapefile to CRS, and now we need to create like a mini dictionary, and over here we need to specify the projection, so PSG 4326. Okay, now if we check shapefile .crs, so now you can see that the projection was changed to 4326. Perfect. So now let's plot the let's make some plots. So what I'm gonna do is I'm gonna plot the raster. So I'm gonna import matplotlib, which is a famous library that is used in order to make plots. So now I'm gonna write the function in order to plot this. Using the function subplots, and now I'm gonna specify the figure size equal to, I don't know, like 10,8. And over here, raster.plot. So this raster is we are calling basically the raster, the variable that contains the raster file in show. With this function, we are able to plot the raster. AX. So we are gonna plot the raster in the same figure that we are creating, and I'm gonna change the color map to CSMIC. Now let's take a look at the raster. Depending on the size of your raster, it will take some time to make the plot. So now, as you can see, this specific color map, it gives you red colors for positive numbers and for negative, blue ones. So as you can see, all of those are, so this is basically Puerto Rico island, and these over here are zeros values, and over here positive values. So what we can do is I'm gonna put the y labels. So let's start with the latitude. Let's put a font size equal to 12, and I'm gonna do the same thing for the longitude. So it should be x and longitude. So, and let's create a title. So I'm gonna put a title. So it should be DEM, detail elevation model of 10 meters resolution, 10 meters. So now, as you can see, okay, let's wait for it. Now latitude, longitude, and the elevation model. So now what I'm gonna do is I'm gonna relay the raster, and I'm gonna basically locate the shapefile that we're gonna use to clip the raster. So let's overlaying raster and shapefile. So basically I'm gonna use the same code, and over here I'm gonna add something. So I'm gonna change this to shapefile. Let's add this. So I'm putting the same figure, and basically I'm gonna add the shapefile. The polygon that we are gonna use to clip the raster. And let's wait for it. So as you can see, this will be the polygon that we are gonna use. This is the whole raster, So what we are gonna do is we are gonna clip the raster by using this polygon over here. I'm gonna change this to jet. Perfect. So now we can see, and this is another color map. Okay, perfect.